Necessity is the mother of all invention. The same applies for the need for something better, or to say, more advanced in mobile communication. The growing need for faster and more effective communications is the driving force behind the state-of-the-art mobile technology. With that being said, in just a matter of a few more years, the era of the digital world presents new and improved 5G mobile technology. But what is this 5G or smart home, and how does it all apply together? The solution is in the making and currently in process. But what we do know is that the dawn of this latest technology is coming soon, and will mark the revolution in the way we live forever. Before that, let's take a journey back to memory lane and cellular technology. The evolution of cellular technology began with 1G, also known as the first generation of mobile communication. Analog signals are used as a form of radio signals to communicate over mobile devices such as the telephone. These signals are sent to the radio tower, and then to the receiving end of the line. Data capacity with 1G is only 2 kilobits per second. Then comes the second generation of mobile technology, which integrates the SMS or short messages services in mobile devices. The signal in mobile calls are made in the form of digital signals, no longer in analog. Data capacity for this mobile technology is increased to 10 kilobits per second. After that, the age of Internet and mobile devices begin with the help of the third generation of mobile technology. Users are able to watch their favorite movies and bond with their favorite people globally with apps online. With 3G, data capacity reaches up to 384 kilobits per second. While its mobile technology predecessors use circuit switching, 3G is the first generation to make use of packet switching and circuit switching. With the existence of the current fourth generation, we are able to reach greater height in Internet connectivity speeds, making an upgrade in the digital world with speeds up to 10 times faster than 3G. Information is sent within a matter of seconds. But as more and more devices are connected to the Internet, soon, even the fourth generation network will be crowded. A solution has to be made. Communications has evolved so vastly and rapidly where the contemporary fourth generation is deprived of the potential to supply for the up-and-coming Internet-connected devices. Thus, 5G is the solution to this. This fifth generation of mobile wireless technology is built upon the existing LTE networks. As of now, the mobile technology's predecessors have witnessed substantial increase in peak bit rate. However, 5G has a data bit rate up to 10 times faster than 4G. 5G is expected to bring new frequency bands and wider spectral bandwidth per frequency channel. With the potential of 5G networks, Internet of Things devices such as automated cars, smart home, and smart city in the near future can be supported tremendously. How can this be achieved? Well, researchers have shown that there are 5 technologies that lay the foundation to the birth of this cutting-edge mobile technology. The first technology is millimeter waves. These waves operate at the range of 30 to 300 gigahertz in the radio frequency spectrum. With millimeter waves, more Internet-capable devices can be allocated with more bandwidth for everyone. On the downside, signals transmitted from one device are unable to travel far and weakens when traveling through obstacles such as walls. This is overcome by using small cells. Internet network signals are broadcasted by high-powered cell towers that can span over long distances. With the use of small cell towers that are located closely together, millimeter wave signals can be broadcasted and relayed by these nearby cell towers without weakening the strength of the signal. However, these small cell towers are not capable of handling the network traffic. With more devices on the network sending and receiving data, the network can only withstand so much before it becomes a real traffic. Massive MIMO or massive multiple outputs is a technology that uses a significant number of antennas that transmit and receive signals embedded in the small cell towers to handle and therefore smoothen the flow of data traffic when data is being sent over the network. 5G also comes with the technology of beamforming. As broadcasted signals tends to transmit in every direction, it will inevitably induce interference in the signal. Thus, with beamforming technology, these cell towers are able to steer the signals directly back to the intended device without any loss in the signal strength. Last but not least, radio waves tend to travel both forward and backward at the same frequency band. This will cause interference. Hence, with full duplex technology, different signals will traverse at different frequency paths when transmitting and receiving. 5G fully utilizes packet switching, where data are broken into smaller chunks known as packets and sent across the network. This is considered simpler and cost-efficient compared to circuit switching. 5G uses the modulation techniques known as CDMA and OFDM. CDMA stands for Code Division Multiple Access. It refers to a form of multiplexing, which allows numerous signals to occupy a single transmission channel, optimizing the use of available bandwidth. OFDM, known as orthogonal frequency division multiplexing, is a modulation format that is based on digital multi-carrier modulation method. A large number of closely spaced, orthogonal sub-carrier signals are used to carry data on several parallel data streams or channels. Single data stream is split across several separate narrow band channels at different frequencies to reduce interference and crosstalk. 5G will also adapt IPv6 instead of IPv4, where the former utilizes 128-bit Internet addresses, compared to 32-bit of the latter, as the address space of IPv4 is nearly exhausted. IPv6 also introduces the Neighbor Discovery Protocol that enables multi-protocol interoperability between IoT devices. So, both the number of addressable addresses in IPv6 and the features of the protocol will be critical to the success of 5G. The protocol stack of 5G is mapped with the OSI stack in the following. First would be the OW layer, which is the short form of Open Wireless Architecture layer. It functions as physical layer and data link layer of OSI stack. Next up would be the network layer. It is used to route data from source IP device to the destination IP device or system. It is divided into lower and upper network layers. The Open Transport layer combines functionality of both transport layer and session layer of the OSI layer. Application layer marks the data as per proper format required. It also does encryption and decryption of the data. It selects the best wireless connection for a given service. Now we're done talking about 5G. Let's move on to smart home. Smart home is the automation process to manage and control premises environment with technological elements or units that are enabled to communicate with a central unit or gateway through a control entity of software, panel, web management interface, etc. with objective to simplify life and improve efficiency. The devices can be controlled remotely from anywhere, be it outside of your home or other side of the world. Home automation went through different stages, starting with central machine or gateway controlling the units, then the introduction of artificial intelligence units that support any other center units, and the introduction of smart robots which could be delegated to perform a task. Some of the smart home devices include Netgear Q, iHome, Smart Plug, and Philips Hue Wide LED Starter. The common communication protocols used by smart home devices include X10, which is used in remote controlling, 6LoWPAN, which is a combination of IPv6 and low-power wireless personal area network, and Bluetooth LE, which is low-power Bluetooth. Other protocols that are used as well would be Zigbee, Z-Wave, and RS485. All of this protocols use on low-energy radio waves to communicate from appliances to appliances, allowing for wireless control of residential appliances such as lighting control, security systems, and many other systems which form smart homes. There are many appliances which is made available for consumer use. For example, we might have seen some places which use motion sensors in their lighting which detects human presence and turns the lights on and off accordingly. Other examples include audio-video systems which accept voice commands as a controller, security, and surveillance systems which allows us to view and control the cameras when we are out of home, and smart curtains that use trackers and sensors to detect sunlight. The main purpose of smart home is to make life more convenient and to reduce human effort. For example, having a smart thermostat reduces power consumption because it automatically controls the temperature of the room accordingly, and at the same time it also reduces our effort to control the temperature. Now and then. This is implemented throughout the house, so if there is no one in the room, an air conditioner, for example, automatically turns off. Several other benefits of having a smart home are, it makes a better place for disabled and elderly people. This is because they might have limited capabilities or movement, so it might be hard for them to do things at normal pace. Instead, they can use a tablet to control their home devices. So how does the fifth generation of mobile technology integrate into smart home? 5G makes smart home more effective because of its high data transfer rate and low latency, which makes data communication more seamless and smooth. Both high-quality media delivery and smart home applications represent strong use cases for 5G fixed wireless access. IoT technology is dependent on the interconnectedness of multiple devices on one platform, and 5G technology provides just the right base for its success. Imagine getting notification from smart home cameras on your phone when a package is delivered to your doorstep. That's precisely the kind of thing IoT and 5G technology together can achieve. 5G IoT devices will use narrow bandwidth to support thousands of things per silver device, offer prolonged battery life, and provide deep coverage in challenging areas of meter. Smart home systems have reached commercial maturity with the appearance of smart appliances on the market. The revolution is expected to create small house-wide ecosystems in which appliances from different vendors and applications created by different developers can interoperate seamlessly. Although availability of connected appliances using standard interfaces and protocols is already in production, supporting local applications that can run in proximity of smart objects is still a work in progress. In the near future, 5G will open up many possibilities for IoT devices in smart homes.